Hi guys, welcome back to our lesson. So we are still looking at the concept of inductive reasoning, right? This is all about trying to measure and observe and then make a conjecture, refine it after we disprove it, and then prove it with deductive reasoning. Now we're going to look at the concept of when we have some midpoints of the triangles and drawing a line through those midpoints, and what does that do to our triangle. But let's just look at it so that I don't then make you not know exactly what we're talking about. So just remember, we're always going to look at you remembering what this inductive reasoning is about. I said observe and measure, develop, test, disprove, refine, and then prove again. Now, here, one of the conjunctures that we can try and make here is, in a triangle ABC, a line drawn parallel to the third side of the triangle, right, which is AB. What is it that can we say about this, right? And at a later stage, you will see that it's one of the theorems that you actually have in Euclidean geometry, right? That it actually passes through the midpoint. But I want you to think about that, and we're going to investigate it to say, really, is that the case at all times? Or is it just a special condition when it is passing through midpoints, and then there's something else that we can know based on that, right? So if we look at this, we're saying the line drawn parallel to AB joins the midpoints of AC and BC, which is just what I said to you, right? So in simple terms, it tells us if I make this to be D and that E, AE will be equals to EC, BD will be equals to DC. That's what it simply means, right? That's what this conjuncture is saying. But is this true for all of the conjunctures or not, right? Or all of the triangles, I mean. We really don't know. So let's try and see whether this is actually true. Now, if we look at this diagram that I have here, right, you can see that if I have DE being the line parallel to AB. I just really can't show the parallelness here with my arrows, but I try to show it with the angles. You can see that 120 plus 60 will be equal to 180 degrees, which will make it co-interior angles, right? It doesn't really matter how you move this particular shape. At all times, it will always be the very same thing that we are trying to say here in this triangle, right? Where if I move it like that, it will forever be when it is passing through the midpoint. That white line, don't worry much about it. I'm gonna really address it just now to show you exactly what that one is about. So you can see that with this particular theorem or this conjuncture that we have here, it's not always the case that any line drawn parallel to AB joins the midpoint of AC and BC, right? But now, if we try to disprove this particular thing by using what we call the deductive reasoning, you will see that if I claim, right, that this is a triangle, and then I draw a line that is parallel to that line, there is really no way of me proving that this line is equal to that line, or this line here is equal to that line using the deductive reasoning, because there is no theory behind us talking about that, right? So when we're trying to now refine this, we will then say, firstly, how can this be looked at if it's the inverse of it, right, or the converse of it? It means that if I say I have a triangle ABC, the line that joins the midpoints will forever be parallel to the third side. This becomes true because, yes, the condition is that it must be passing through the midpoint of the two line segments, right? But can it be true if it's not passing through the midpoints of the line segments? That's what we are really battling to try and understand here is it really true that even if it's not passing through the midpoint, for any triangle that we have, will it still be parallel to the third side or not? And that's what we need to look at, right? Because this will then say, if any line is drawn parallel to the third side, it is passing through the midpoint. But that is really not a true statement at all times. But let's look at this. So we're saying the line that joins the midpoint is parallel to AB that we've just spoken about. Now that it is actually going to be the case, right? This will be midpoint of that. So this is A, D there, and then B here. This is equals to that, and this is A, E, C, and this is also equals to that. There's many ways we can try and prove this, right? Because you will see that this angle will be equal to that angle there because of corresponding angles, and then this angle here will be equal to that angle there. And then you can try and talk about having an isosceles triangle where you will then make a claim that this side is equal to that side, right? That's what you can try and do. And then one thing also that we are saying is if we're trying to prove the converse of this conjuncture, we will also be using the very same thing where we consider the concept of similarity or congruency that we're going to look at. However, that's not really what we want to focus on more here. The concept is just to try and investigate what this concept of drawing a line parallel to the other two lines, what does it really do for us? Now, I want to show you something as well with this line of mine that I said I was going to show you, right? Because remember what I said. They said if we draw any line parallel to AB, this line will be passing through the midpoints of the two line segments. Now, if you look at this, right, if I put it on the line like this, it simply tells me that this line is parallel to this line, right? But do you see, I can put it here. It is still parallel to it. It does not mean that it is passing through the midpoint because the midpoint is E and D. I can also move it up there. It is still parallel. It does not pass through the midpoint of BC and the midpoint of AC, but it is still parallel. Even if it does pass through it, it will definitely be parallel to it. So do you see, it's not just about it passing through the midpoint only. And that's what I wanted you guys to see in terms of the flaw that we can find to try and disprove this particular theorem that we are talking about here, or rather this conjuncture, that it must only be passing through the midpoints. That's not the case, guys. Guys, I really, really hope all of this is a bit clear on how to try and investigate Euclidean geometry, right? Just to summarize everything we've looked at, we said inductive reasoning is a statement we make based on observations and measurements. It has nothing to do with theorems. No, you draw, you measure, you draw, you measure, you draw, you measure, and then you make a conjuncture. This conjuncture will be what leads to a conclusion that if A is true, then B will definitely be true. And then we looked at the converse of this, right? But the process of this inductive reasoning, we said, is all about observing and measuring and then trying to provide or form a conjuncture to say, I know that if it passes here, this is what will happen. If it goes through that point, this is what will happen. So it's all about what did you see with your eye. That's why I'm keep on using my hands just to show you. If you see this, it simply tells you this, right? Same as if you see that, it tells you this. So that's what we are trying to say. That's what a conjuncture is. You test it by performing several measurements and observations, and then you refine it. If there's changes that need to be made, you prove it using the deductive reasoning, and then from there you can then try and link it to a certain theorem that we're talking about, guys. But right now we actually have come to the end of our lesson. I really, really hope you are clear now on the difference between deductive reasoning, which is using the properties that are already set, and inductive reasoning, which uses what we see after we try and measure and draw. But from me to you, I hope everything is clear, and you can always go back and do your own research, please. Because remember, I always say, don't take everything I say as is, right? If you don't understand something, don't just say because he said that, then it's correct. Go investigate so that it can make more sense. Mathematics is food for the soul. Until next time.